For section 3.4, we are going to be talking about slope and how it relates to parallel and perpendicular lines. Let's do a recap on slope and how you find slope. So remember that slope from a graph, you're looking at the rise over the run. Okay, so we're going to put the rise number on top and the run number on bottom. So rise is going to be the vertical movement of the line, and the run is going to be the horizontal movement. So identify 2 points that it goes through, and then just look at the rise and the run. And then you just count those. So 1, 2, 3, 4 for this rise, and 1, 2, 3, 4, 5 for the run. And I don't do the rise and the run as positive or negative numbers. I look at the overall slope of the line as positive or negative. So for this one is going down. So this would be a negative 4/5 slope. So you always read a graph from left to right. So we would start on the left-hand side, and if you can imagine a hiker or somebody walking, if they're going uphill, it's positive. If they're going downhill, it's negative. If they aren't going up or down, they're just going flat, then that's a slope of 0. And then if they couldn't do it, like they can't walk like this, they'll just fall straight to the ground, that is an undefined slope. Then we can do it between 2 ordered pairs, which is still looking at the rise versus the run. Okay, the rise being the vertical movement, which would be the change in your y coordinates. So you would subtract your y coordinates to get the rise, and you would subtract your x coordinates to get the run, since the run is the horizontal movement or the difference in the x's. So what I like to do here is put this in a table to do your subtraction. So put your first ordered pair on top and your second ordered pair on bottom. Then you can think, so you can subtract these, so you can literally type in -4 minus 7 if you would like. I like to just figure out how far it is, since we're looking for the change here. So how far is it from -4 to 7 on a number line? And that's a change of 11. And how far is it from 2 to -1 on a number line? So that would be down 3 or a -3. So then slope is the rate of change, and it's the y's over the x's. So you have these y coordinates on top and the x coordinates on bottom. So we're going to take this number here, 11, that's going to be your rise. So that goes on top. And then your run, okay, which is the difference in your x's, goes on bottom. So we have a -11/3 slope as your overall slope. And so you can write that with the negative out front like this. In the middle, you can write the negative on top with the 11, or you can write it on the bottom with the 3. All of those mean -11/3. And then finally, if you have it written in slope-intercept form for an equation, so if you have it solved for y, so y has to be by itself, then it's this number in front of the x coordinate. Okay, so it's the m, right, or not x coordinate, but in front of the x variable. So it's the m right in front of there, the number. So in this case, your m is -3. Then when we talk about with parallel and perpendicular lines, so the thing to remember is that when you have parallel lines, their slopes are identical. Okay, they have to be slanting at the exact same angle, meaning that their slopes are going to be identical. With perpendicular slopes, you'll notice that you have one slope that's negative, one slope that's positive. So if you remember back to those hikers, you'd have one person going down and you'd have one person going up. So you're going to have a positive and you're going to have a negative. And then in order to get this right angle, you're going to have a steep line and a not so steep line, meaning reciprocals of each other. So we're going to have opposite reciprocal slopes. Opposite reciprocals also multiply to 1. That's why this says a product of -1. So we could have a slope of 2/3 for one of the lines. Then the perpendicular slope is going to be the reciprocal of that and the opposite. So -3/2. Or you could have a -4 slope, and the perpendicular slope to that is going to be the flip. Okay, which there's a 1 under here, so it's going to be the flip of that and the opposite. So this was negative, so this will be positive. Let's take a look at a couple examples here. So draw a line representing the rise and a line representing the run of the line, then state the slope in simplest form. So let's go ahead and get the rise and run on here. So I'm going to do the rise in red. Okay, so find any 2 points. Maybe we should do that first. So find two of these like lattice points that it goes through. So it looks like it goes through that point. Look for another one, this one. And then you can go ahead and do your rise versus your run. So here's my rise, the vertical line, and then you want to do a run, horizontal line here. Then you'll count those. Okay, so actually figure out how tall this rise is. 1, 2, 3, 4, 5 units. And this run is 1, 2. So for your slope is going to be, again, the rise over the run. Okay, so it's going to be the rise over the run. And your rise number here was 5 versus your run is 2. Okay, then you also want to check the hiker. So is your hiker going up or down? And in this case, the hiker is going down. So it's going to be a -5/2 slope. And then we would see if this was simplified, if this could simplify at all, we would simplify it, and this one cannot. Another answer you might have gotten here if you didn't pick consecutive points to connect, you might have gotten something like 10/4. This would just need to be reduced. So each of these could divide by 2 and get you to 5/2. So make sure you reduce those. What's the slope of a line that passes through the points 7, -6, and 4, -6? Write your answer in simplest form. So this one, anytime there's just ordered pairs and there's no graph given, I like to just write them into the table. So I'll put 7, -6 on the top and 4, -6 on the bottom. Then we're going to do our rise and our run. So looking at how far it changes for the y's. So how far is it from -6 to -6? Well, that didn't change at all, so that's a 0. How far is it from 7 to 4? So that one is down 3. So then we will remember that our slope is going to be the change in the y's over the change in the x's. So the y part always goes on top. Okay, so our change in y's was 0, and our change in x was -3. And then simplify this, so 0 divided by -3 is 0, so your slope here is 0. A lot of people will get this wrong on accident, the ones with zeros in them. Remember, if 0 is on the top, it's 0. If this were flipped over and it was -3 divided by 0, you can't divide by 0, so this would be an undefined slope, okay? In which case it's a vertical line like this, versus ours right here, if we were to graph this and go to the point 7, -6, and then 4, -6, and draw a line, this one's a horizontal line with a 0 slope because your hiker isn't going up or down. So this one is 0. What is the slope of line parallel to a line with this equation? Okay, so one thing we need to remember here is that for parallel lines have the same slope. So we need to figure out what the slope of this line is and then pick the same one. So I'm just going to rewrite this equation over here, because in order to figure out the slope, we want it in slope-intercept form, which means that it's solved for y. So we're going to go ahead and get our x on the other side by subtracting 4x from both sides. So we're left with -2y equals, and then I like to write the x term first since these aren't like terms. So I'll write the x term first, and then -12, so -4x minus 12. Now we need to get y by itself by dividing by -2 to both sides. So -2 divided by -2 is 1. Negative 4 divided by negative 2 is positive 2, and then you have that x. Negative 12 divided by negative 2 is positive 6. So then we'll identify the slope here. Remember, the slope is the number in front of the x. So our slope of this line is 2. So a parallel slope is going to be the same, and it's going to be 2. So sometimes instead of writing parallel, I'll just draw those two lines that mean parallel. So parallel slope is 2. If we had wanted a perpendicular slope, remember for perpendicular, so this is the abbreviation for perpendicular. So a perpendicular slope, remember, would be the opposite sign. So this is positive 2, so the opposite would be negative 2. And then we also would need to flip it. So the perpendicular slope would be negative 1/2. Parallel, exact same. Perpendicular, opposite, reciprocal. So these ones say what's represented by these lines. Are these parallel? Are they perpendicular? Are they the exact same line, or are they neither? So what I would do is solve these both for y, get them into slope-intercept form. So let's take this first one and solve this for y. So we've got 5y minus 10x equals negative 30. So remember, we want to get it in slope-intercept form, which means solve for y. So we're going to want to bring this x term over. So we end up with 5y equals, and I like to write the x first, so positive 10x minus 30. Divide by 5 to everything. So then we end up with y equals 10 divided by 5 is 2x. Negative 30 divided by 5 is negative 6. Then we're going to do the same thing for this next equation. So y plus 2x equals 4. Let's solve for y. So we're just going to subtract 2x to both sides. So we end up with y equals negative 2x plus 4. So now we'll just analyze the slopes of these two lines. So the slope of our first line is 2. The slope of our second line is negative 2. So in order to be parallel, they need to be the exact same, which they are not. One is positive, one is negative. To be perpendicular, they need to be both opposites, which they are, and reciprocals, so flipping the fraction, which they are not. So we had the opposites, but we didn't have the reciprocals. Exact same line would have everything the same. It would say 2x minus 6 and 2x minus 6, which it does not. So these are neither parallel nor perpendicular.